parts of circuit may be divided into three parts. Okay, 1 minute. So parts of circuit may be divided into three parts. One is first is defined as a branches. Okay, branches that are also defined as a resistance या resistors or resistors. Number two are nodes, that is also defined as the junctions. Third is loops, and some books like write mesh. Okay, so started from the branches, resistors. When we analyze the circuit, we divided it into the three parts. One is defined as one part is defined as branches or resistors. The other part is defined as nodes or junctions, and third part is defined as a loop and meshes. Okay, what are the branches? As you know from the name, that is the resistance. Okay, so resistance are the second are the nodes. The points where two or more than two resistors or resistance. Yes, yes. The points where two or more than two branches or resistance join are defined as nodes. Okay, and loop branches is a resistance, simply resistors. Okay, loops, it is number of branches. Number of branches is equal to number of resistance. Similarly, number of loops. When branches join to make a closed circuit, it will be defined as loops or mesh. Okay. Kirchhoffs law. Kirchhoffs law. What is the Kirchhoffs law? There are two laws. Okay. Number one, total current passing through any nodes will be always 0. Total current passing from one nodes, that will be always a 0. Okay. Secondly, what is the meaning of this? So first law is total current passing through any nodes will be a always 0. Okay. Total net when we sum. Okay. There are two ways. One way is that we consider that the current moving away from node is positive, or one way we may take it is a negative. Okay. For example, if we are taking the current moving away from the node is positive, then current moving toward node is negative. Reverse is also true. Why? Because if you are considering this positive, this negative, that is 0. If you will multiply with the negative sign, then the direction will be reversed. Okay, then positive will become a minus, and minus will become a positive. So if you consider it is negative, then it will be taken as a positive. If you consider that is positive, then this will be a negative. Okay, and so in this way the total current will be a 0. Okay. So both possibilities is true. If you are considering it is a positive, it is a negative, then it will be positive. If you are considering it is a positive, then it will be a negative. Why? We know that the when we multiply negative sign with the 0, the answer will be a 0, and the parity of the left side will be a change. Okay. So for example, 1 minute. If this is a node, one minute. Yes, 1 minute. If this is a, for example, if this is a this circuit, okay, Okay. If we are considering the outgoing current are a positive and incoming are current are negative, okay, there are two ways. We may consider the outgoing is positive and incoming is a negative. The other way is that we consider that incoming is positive and outgoing is a negative. Okay? Okay. In this case, we are considering outgoing positive and incoming is a negative. So let's suppose from R1 is current I1. If we are incoming is zero, sorry, negative, then our I1 will be negative, I2 will be positive, I3 will be positive, I4 will be positive, I5 will be positive, I6 will be a negative, I7 will be a positive, and I8 will be a positive 0. Okay, got it? Now you, Mr. R1 is because it is outgoing. This will be a, if I considering that away is negative and incoming is a positive, 1 minute, then R1 will be away, sorry, okay, sorry, okay, sorry. R1 is a negative, positive, okay. If we are considering the R1 is inward, R1 is a negative, R2 is a positive, R3 positive, R4 positive, R5 positive, R6 is a negative, R7 is a positive, R8 is a positive. If we multiply with the minus sign, then positive will become a minus and minus will become a positive. So, or you may say that will be mentioned in the numerical or a problem. This example is given, okay, and this is your result. Okay, you will analyze from this circuit and then you will, or you may write, you in the reverse case you may consider that incoming is a positive and outgoing is a negative. In some books we write the incoming is a positive and outgoing is a negative. So you may write in this way. So both are true. This is also true and this is also true. Both are true. Okay, but total current, because when we multiply with the negative sign, the parity will be changed. Okay. So this is all. This is about the first law. What's about the second law? Second law of Kirchhoff. Yes. What is the second law? Total voltage drop across the loop will be a 0. For closed loop will be a 0. Total voltage dropped across closed loop circuit will always a 0. Okay, total voltage will be a 0. For this you have 3 points. Okay. You will consider induced EMF or voltage of battery. Okay, this is a voltage of battery or induced EMF. Okay, electromotive force or induced EMF will be negative, will be positive when current is will be a positive 1 minute one will be positive when current moves from positive terminal to negative terminal of battery. Okay, 1 minute. So, will be positive. 1 minute, I will explain it later. You consider only the positive. The voltage drop will be a positive when current move from positive terminal of battery to negative term. Okay. B will be negative or positive when current moves from negative terminal to positive terminal. Okay. If current is moving from negative terminal to positive, then we will consider it negative. Okay. C part, V voltage V equal to IR, voltage dropped will always 1 minute will always consider, if you are considering this case, then that will be a, it will be always positive. There will be a no change in sign. Okay. Yes. And that now the question is why I'm writing. Now I will explain it. Okay. Firstly, consider this. If the current is moving from positive to negative, we will consider it positive. If we considering the current from negative to positive, we consider it will be reverse, that will be a negative. And voltage drop will be always considered the positive. So for black, this is true. For blue, this is true. If you are considering that voltage from positive to negative is a negative, because the voltage is dropping when current will be move. Okay, if you consider this is negative, then this will be a positive, and the current will be the voltage drop across battery will be always a negative. It's up to you what you will prefer. I think this is a more easy, because you are considering it always positive. Okay, you may consider it always positive, then this will be a negative and this will be a positive. If you consider that this is a negative, that voltage, if the current is moving from positive terminal to negative terminal, if you are considering it negative, because the voltage is dropping when current moving from positive to and the current is voltage is increasing when current is moving from negative, because if you are considering it negative, if it is a positive, then you will consider it as both are EMF, both are the terminal of the battery. This psi, I will explain it with the example. Okay, this psi will be this voltage of battery will be considered positive if you are moving from positive to negative. If you are considering the current from negative to positive, then it will be a negative, and this will be always positive. I explain it with the example. Okay. Yes, beta. Yes. This actually, because this total is zero. Okay, that is not related to that is generally true. Okay, because it is a negative, and we now the property of the negative is that if we multiply with the minus sign, when zero multiply with any number of non-zero number, the result will be the remain. So if we multiply with the minus one, for example, total voltage is equal to zero, and left side is, for example, if x equal to 3, sorry, x minus 3 equal to 0, then then this will be true, because when we multiply with minus 1 both side, the parity of this left side will be changed, but right side will be remain the 0. For example, if I multiply with the, it will remain the 0. And so the positive will become a negative, and negative will become a positive. So this is also true, and this is also true. Okay. Due to this mathematically trick. Yes, mean they will be. You are, you have to consider, you have to choose one positive, negative, positive, or negative, 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 positive, negative. It's up to you. I think that is a more simple if you consider that this is a positive, this is a negative, and this is a positive. Okay, got it? That is a mathematical trick. It is not related to the type of the problem. As I have already explained in the previous lecture, acceleration for attractive force is always negative. Actually, the direction of the point is important. If you are moving A to B or a B to A. If you are throwing upward, the acceleration will be a negative. If you are throwing downward, acceleration will be a negative. But the change of the sign will be related to the traveling. It is moving from lower to higher or higher to low. Acceleration will not. Similarly, it is not related to problem. It is depend upon your choice. Okay. If you are considering the positive terminal to negative terminal is positive, then negative to positive will be a negative. This have a unique. If you choose the positive, then it will be a positive. It will remain a negative. इसका साइन नहीं चेंज होगा, सिर्फ इनका साइन चेंज, ठीक है. But if you are considering this positive, this, if you are considering this convention positive, negative, positive, or you may choose this convention, blue convention. You have a choice to choose any one of them, black or blue. Okay. Okay. I think black are more simple. Confusion, ठीक है. Because this is a simple. I think that's why I am preferring to this. Okay. But both are true. Okay. And for example, That is second law, example of the second law. Okay. Small terminal means negative terminal plus small terminal. If you're considering that this and this, 1 minute, 1 minute. If you are considering this is a circuit, okay. This small terminal will be defined as a negative, okay. Large will be a positive, okay. Okay. This will be a negative and this will be a positive. Now it's up to you. You may consider clockwise or you may consider the anti-clockwise. So it is a choice up to you. No, it's okay. I explain it. 1 minute. Okay. Uh, this is given circuit. It's not up. This is given. Okay. And now this is I1, I2, I3. There are 6 batteries. 1, 2, 3, 4, 5. Okay. And this is resistance 1, this is resistance 2, this is resistance 3, this is resistance 4, this is resistance 5, this is resistance 6. Okay. What are the junctions? Okay. These are the yours. This is the given. Okay. Yes.
पहले हमने जो बनाया था सर्किट मतलब प्लस वाला साइन था पता नहीं क्या था वो किस
But that was only in explaining the how we will consider the current. Now we are explaining the second law example. Yes, example of the second. Okay. 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 So according to if we consider that current is anti-clockwise, okay, you are interested to clockwise. Clockwise is like this. Okay, so you are interested. I must write. Okay, okay. If we consider the current is clockwise, then negative to positive. If we are following this negative to positive, positive to negative is a positive, and negative to positive is a negative, and current will be always positive. Okay, so we are following the black law. Okay, black color. Okay, okay. So negative to positive is negative. This will be a again negative to positive. This is a negative. This is a positive to negative. Positive. Positive to negative. Positive. Negative to negative to positive. Negative. Positive to positive to negative. Positive. Okay. So this will be the EMF, and all R's will be a yeah. Current is same, so we may take the current common. R1 plus R2 plus R3 plus how many? R6. Okay. R4, R5, R6. Okay, and that will be a 0. Okay. Or you may say that. So if we move it on the, if we shift it toward the left, then psi 1 plus psi 2 minus 3 6. This will be example. This question 5. Okay. We have considered the black rule. You may use the blue color rule. Okay. Clear? And you may consider the current clockwise or anti-clockwise. It's up to you. Okay. The result will remain the same. Okay.
तो ये ऊपर जी सर अभी देखिए जब क्लॉकवाइज चल रहे हैं करंट फ्लो कर रही है से अभी भी पॉजिटिव सर जाएगा तो क्या होगा
when you join,
ये E2 का पॉजिटिव है ठीक है अब ये इसी का पॉजिटिव है जब क्लॉकवाइज फ्लो कर रहा है पॉजिटिव इससे पॉजिटिव पे जाएगा तो क्या होगा
yes, you are good. That is good question. When positive with join will positive, and negative in the same as if negative. So the sign will be different. Mean they will be a subtract. They will not add up. But if you check your batteries always connected in this way. If you connect in this way, positive with negative, then this will be the voltage will be added. But if you have the positive with the positive and negative with the negative, then the voltage will be cancelled. Because according to this law. So आपको सोचना नहीं पड़ेगा. इस लॉ की सबसे खूबसूरत बात यह है कि ये खुद जो है वो उसको कर no. In both cases they will be equivalent. Yes. For example, let's consider on numerical. Okay.